Right now, drifting through the freezing darkness of interstellar space, there are billions of starless rogue planets wandering the void. When we search for extraterrestrial life, we obsessively scan the narrow Goldilocks zones of warmth immediately surrounding bright stars. But early solar systems are violently chaotic. Close gravitational encounters regularly eject newly formed worlds, from Jupiter-sized gas giants to smaller rocky bodies, flinging them entirely out of their star's orbit and into the abyss. Out there in deep space, without a star to warm them, the surface temperature of these orphaned planets quickly drops to minus 270 degrees Celsius. They become frozen, pitch-black graveyards. Yet, wrapped securely beneath miles of ice, these wandering worlds might actually be the most abundant cradles for life in our galaxy. Here on Earth, we get almost 99.9% of our energy budget directly from the sun. If you take that away, how can a starless world keep an ocean from freezing solid? The answer relies on a mechanical engine known as tidal heating. If a rogue planet has a large moon, gravity pulls on it. This repeatedly stretches and squeezes the planet's interior, generating massive heat deep within the core. That heat radiates upward, hitting a thick ice shell that traps it, maintaining a pressurized subsurface ocean. We know this exact mechanism works because we see it in our own solar system. This is Enceladus, an icy moon of Saturn. Its cracked surface hides a massive underground ocean, kept liquid by the gravitational pull of its host. In the extreme cold of the cosmos, a freezing surface doesn't equal a dead world. A thick ice shell is actually the ultimate protective insulator for a liquid habitat. Even with liquid water, biological organisms need a steady supply of chemical energy to survive without sunlight for photosynthesis. To replace the sun, these worlds rely on an invisible power source raining down through space, highly energetic galactic cosmic rays. This table shows the energy deposited by galactic cosmic rays in various subsurface environments. High-energy secondary particles penetrate the ice and trigger radiolysis, splitting water molecules into metabolic fuel for microbes at a rate mathematically comparable to radioactive rocks. There is a physical limitation to this environment. Lacking wind, tides, or weather systems to stir the water, a deep subsurface ocean suffers from an incredibly slow vertical mixing regime. Because nutrients aren't easily distributed, any resulting ecosystem would be highly localized. Microbes and more complex biology must huddle tightly around active hydrothermal vents, extracting their chemical energy directly from the source in complete darkness. These biological pockets are small and trapped beneath impenetrable rock-hard ice. But they are incredibly secure, shielded entirely from extinction events that plague surface worlds. That thick ice shield offers a massive advantage in biological stability. A rogue planet's internal heat can maintain a habitable subsurface ocean for up to 4.3 billion years, completely immune to solar flares or the eventual death of a host star. Earth-like surface planets are actually fragile anomalies exposed to a dangerous universe. Rogue icy moons are the true durable baseline for habitable real estate. This stability has led researchers to a radical concept known as the cosmic hitchhiker hypothesis, which proposes a unique solution for advanced extraterrestrial civilizations facing an existential threat. Rather than spending centuries building fragile, resource-limited spaceships, a spacefaring species could intentionally colonize a rogue planet. They could move their populations underground and use the world's vast, self-contained oceans to cross the galaxy. Through advanced astronomical engineering, they could steer these massive worlds, riding a resource-rich rogue planet straight through the chaotic, violent void of deep interstellar space. The dark space between the stars is actually a teeming superhighway of hidden oceans. And the next time a rogue world passes by our solar system, we should probably be listening.